in inorganic chemistry. So let us see 13th and 14th also from P block elements. From P block elements. That we'll see today. Then tomorrow we'll see organic chemistry. Tomorrow I'll start first PU organic chemistry. Done. Okay. So let us see 13th and 14th group elements today. P block elements. What is today's topic? P block elements. Okay, let us start P block elements. Okay, P block we have 13th group and 14th group elements. So first let us see group 13. This is also known as boron family because the starting element is boron. Then what are those elements? Boron, aluminum, gallium, indium, thallium. So these are elements present in it, atomic numbers. Boron, 5 plus 8, 13. 13 plus 18, 31. 31 plus 18, 49. 49 plus 32, 81. So general electronic configuration is NS2 NP1. The general electronic configuration NS2 NP1. So what will be its valency? 3. Common oxidation state will be plus 3, right? So this is about general information regarding then general characteristics. Let us move to general characteristics of these elements. What are they? First one, as usual, atomic radius. Atomic radius. Now, this group is known as, this group is known as a group of irregular trends. A group of irregular trends. Why? Let us start with the atomic radius. So atomic radius of boron is less than aluminum. But aluminum is greater than gallium. Now gallium is again less than indium. Indium is less than thallium. Now here the order is changed. Aluminum should be less than gallium, but here aluminum is greater than gallium. So there is a deviation. There is a deviation, right? Similarly, ionization enthalpy. ionization enthalpy. Let us see order. Boron is greater than aluminium. It is less than gallium. Gallium is greater than indium. Indium is less than again thallium. So there is again some change in the trend. Right? That is ionization enthalpy. Next. Oxidation states. Oxidation states of these compounds. Okay. They show +1 and +3 oxidation states. But boron shows only +3 oxidation state. Thallium exhibits only +1. Why only thallium exhibits +1? This is due to inert pair effect. Next, oxides. If you take oxide of boron, B2O3, it is acidic in nature. Whereas Al2O3, this is amphoteric. Ga2O3, this is also amphoteric. Whereas last, indium and thallium oxides, they are basic in nature. Okay. Next part. Halides. What about halides? So let us see what about halides. They form MX3 type halides. But if you consider boron trihalide, this is electron deficient. So they act as Lewis acids. Then if you take aluminium trichloride, it exists as dimer. It exists as a dimer. How Al, Cl, 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 Al, Cl, Cl. So it is existing as a dimer. Okay. Next, hydroxides. What about hydroxides? From boron hydroxide to thallium hydroxide, the basic nature increases. What happens to basic nature increases, because we know already, so the generalization. What is that generalization? Down the group basic nature of hydroxides increases. Done. That is about hydroxides. Next, compounds of boron. So what are compounds of boron? The first one, borax. What is borax? Na2B4O7 10H2. This is what we call borax. Okay. Next, borax bead test is used to identify metal cations. It's used to identify metal cations. If you treat, cobalt oxide, treat with B2O3, cobalt metaborate, you will get CO, BO2 taken place. This is cobalt metaborate. This forms blue colored beads, which forms blue colored beads in the solution. Whereas Cr, BO2 taken place. Chromium. This gives green colored beads. Ni, BO2 taken twice. This gives brown colored beads. Okay. Next compound, boric acid. That is H3BO3. So it is used as antiseptic for ice. Next, diborane, B2H6. So this is actually BH3, BH3, two BH3 units. Okay. In that, each boron undergoes sp3 hybridization, right? Now, when it comes to its structure, it is having H, 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 H. So these two are called banana bonds. So how many banana bonds? It possesses two banana bonds. Okay, this is one point. Then three centered, two electron bonds are present. Three centered, two electron bonds. That means here you can see BHB. What is it? BHB. So three centered, only two electrons will be present here. So three centered, two electrons, right? So there is one Compound important, diborane. Next compound, borazine or borazole. What is that? B3N3H6. This is also known as inorganic benzene, as it resembles organic benzene in structure, right? So that is about boron hydrides, that is diborane and borazole, right? Next, 14th group elements. We'll move to next group, 14th group elements. So what are 14th group elements? This is also known as carbon family. It's also known as carbon family. So carbon, silicon, germanium, tin, lead. Carbon 6 plus 8, 14, 14 plus 18, 32, 32 plus 18, 50, 50 plus 32, 82. And what is general electronic configuration? Ns2, Np2. Valency 4. Common oxidation state. What it will exhibit? Plus 4. So this is about 14 group elements introduction. Let us see one by one characteristics. General characteristics. What are general characteristics here? So let us consider general characteristics, right? Then let us see first one. Oxidation states. They show +2, +4 oxidation states, and lead Pb is more stable in +2 oxidation state. Next, reactivity towards oxygen. So they form dioxides. What type of dioxides? CO2, SiO2, GeO2. So these three are acidic in nature, whereas SnO2 and PbO2 are amphoteric. Next, monoxides. They form monoxides also. In that, carbon monoxide is neutral. Germanium monoxide is acidic. Tin monoxide and lead monoxide, they are amphoteric, right? Can you find the principles? Then allotropes of carbon. So crystalline allotropes. Crystalline electrodes. Diamond, graphite, fullerenes, amorphous electrodes. Coal, coke, charcoal, all these are amorphous electrodes, right? Diamond. What is hybridization? sp3 hybridization. Diamond is hard and bad conductor of electricity, whereas graphite, what type of hybridization present? sp2, but this is a soft, good conductor of electricity. Then, whereas fullerenes is also sp2. It has soccer ball type structure. It contains pentagonal rings and hexagonal rings also. Okay. Then silicones. What is it? Silicones. Let us see silicones. That first one, straight chain silicones. What are straight chain silicones? Are in presence of silicon and copper, what you're getting R2 SiCl2, right? Now this R2 SiCl2, this is Cl on hydrolysis gives silicon OH here, R. Now consider one more molecule, HO, silicon, R here, OH. Eliminate water molecule, minus H2O. So then what you will get? HO, silicon, R here, O, Si, R, OH. So this is straight chain silicon. Next you will have cross linked silicone. Okay, but you don't need any of those structures. Next, silicates. So what is a basic unit in silicates? Basic unit in silicates is SiO4 minus 4. So that means SiO minus O minus, O minus, O minus, right? So they are tetrahedral. They are arranged tetrahedral. So in this first type, orthosilicates. Example for this, willemite. Example, willemite, Zm2, SiO4, or zircon. What is zircon? Zr, SiO4. Next type, pyrosilicates. So they contain 2 units of SiO4 minus 4. Next, cyclic silicates. What it is, SiO3 minus 2 taken n times, or SiO3 taken n times 2n minus. Example for this is beryl. What is beryl? Ba3, Al2, Si6, O18. Okay, so this is beryl. Done? Now, let us move to some question solving. Let's move to question solving session now. Right, from 13th and 14th group, what type of questions we can expect? So let us see one by one, right? Okay, let us proceed. Okay. Let us see. Question 1. BF3 is planar and electron deficient compound. Hybridization. Now this is the question. Hybridization and number of electrons around the central atom. Options given are sp2 and 8, sp3 and 4, sp3 and 6, sp2 and 6. Yeah. So what is its structure, hybridization, number of electrons? So let us consider BF3. So boron is having 3 sigma bonds, right? Now what is N factor? I told you during chemical bonding. Number of sigma bonds plus number of lone pairs. So how many sigma bonds you can see? 3. Is there any lone pair on boron? 0. So 3 means A on S and remaining will be P. So that is sp2. This first point. Then how many number of electrons around the central atom? How many bonds are there? 3 bonds around the boron. That means 3 into each bond is 2 electrons. Means total 6 electrons. So around the central atom, how many total electrons? 6. So what will be correct option? sp2 and 6 electrons. Done. We'll move to next question. The stability of +1 oxidation state among aluminum, gallium, indium, and thallium increases. Order. Aluminum less than gallium less than indium less than thallium. This is first option. So the generalization here, the stability of +1 oxidation state increases down the group. So remember this statement. That means down the group means aluminum, gallium, indium, thallium. Who is more stable in +1? Thallium. Least stable in aluminum. So aluminum is less than, gallium is less than, indium is less than. Now this is the order. So this is first option. Done. Then we move to next question. Boron compounds behave as Lewis acids. Because of why they behave as Lewis acids? Option, ionization property. Next, electron deficient nature. Next, acidic nature. Next, covalent nature. Consider BF3, BCl3. Already we have seen BF3. In BF3, already we solved one question. What is that? Central atom boron is having how many valence electrons? Here we calculated. 3 bonds around boron. How many electrons are they? 6 electrons. So actually 8 electrons should be present because every atom or molecule should satisfy what it should satisfy. Octet configuration. But it is short of 2 electrons to get octet configuration. To get octet configuration, it accepts 2 electrons. That means due to this electron deficient nature, it is able to accept electrons. Electron pair acceptor is Lewis acid. So what is your answer there? Electron deficient nature. Next. Which are the following structure? Similar to graphite. A, B4C, B2H6, C, boron nitride, D, boron, which is having similar structure to graphite. Okay. Answer is boron nitride, because boron nitride is known as inorganic graphite. It has similar structure to graphite. That is, it is termed as inorganic graphite. Right? So next, the type of hybridization of boron in diborings. Options: sp3, sp2, sp, lastly sp3d2. In diboron, what is the hybridization? sp3. The next question. Which of the following oxidation states are most characteristic for lead and tin? Options: +2, +4, +4, +4, +2, +2, +4, +4, +2. Okay, this is carbon family. This belongs to carbon family. Then how we can we know that down the group, that is 14th cell. The stability of +2 oxidation state increases. Who is down the group? Lead. So it is more stable in +2. But what is the common oxidation state actually? +4. So lead will be more stable at +2 and tin will be more stable at +4. What is that option? First option. Then one more question. Which of the following compounds is used in cosmetic surgery? Options: silica, silicates, silicones, zeolites.
So zeolite.
Zeolites.
Yes.
Zeolites, they are used for softening of water. So we have seen that, right? During the removal of permanent hardness of water, artificial zeolite, that is what we call permutate. So here answer is silicones. Okay. Next, the substance used as a smoke screen in warfare is, one is silicon tetrachloride, phosphine, PCl5, D, acetylene. Again, answer is silicon tetrachloride. Next, which one of the following statements? Which one of the following statements about the zeolite is false? Which statement is false regarding zeolite? They are used as cation exchangers. Next, they have open structure. Next, C. They are aluminosilicates. Last option. Sum of SiO4 minus U units are replaced by LO4 5 minus and LO6 minus 99 ions in zeolites. Okay. Now, which statement is false? Now, here, zeolites, they are used as cation exchanges. Where we are using them as cation exchanges. In softening of hot water. Yes, that is true. They have open structure. Yes, that is true. They are aluminosilicates. That is also true. Wrong is SiO4 units are replaced by. They are not replaced by Al4 5 minus or Al06 minus 9. So this is a wrong statement. So, but answer is D, because we need wrong statement only. Next, the basic structural unit. The basic structural unit of silicates is SiO3 minus 2, SiO4 minus 2, SiO minus, D, SiO8 4 minus. So already I told you the basic unit of silicates. What is that? SiO4, sorry, what is that? SiO4 is third option. Sorry, here I'm changing. It's option SiO4 4 minus. So correct option D, SiO4 4 minus is basic unit. Next, percentage of lead in lead pencil is here 80%, B 20%, C 0%, D 70%. And what is the correct option? So what is lead pencil actually? What is lead pencil? Does it contain lead? Lead pencil is actually mixture of graphite and clay. Now in this, do we have lead? There is no lead. So what is the percentage of lead in lead pencil? 0. What is percentage of lead in lead pencil? That is 0, right? So that is about some important questions from 13th and 14th group elements. Maybe tomorrow morning we have 7 to 8:30 class that Lavanya ma'am will inform you. So then I'll start organic chemistry. So I'll try to finish first chapter, that is some basic concepts in organic chemistry. Very important and very important topics are there. So Lavanya ma'am will confirm you that tomorrow. So I'll try to take class from morning 7 to 8:30, right?
Yes, sir.
Okay, then that's it for this day. Tomorrow we'll meet again. Good night, all of you.
Sir,
Yeah, tell me.
excuse me, sir. Could you please send a note, sir?
Okay, I'll send it in a group. Then you just take a copy of it.
Yes, sir.
Okay.
Thank you, sir.
Okay, then. Good night, all of you.